All right, today we are going to continue looking at division of polynomials, but we are going to look at division using a different method called synthetic division. And this is going to be something very different from what you've seen before, but I think you're going to like this method because it goes a little faster than long division. And I just feel like there are a few less opportunities for errors in this one. So let's see what you think. Another method of dividing polynomials is called synthetic. Basically, we get rid of the variables and the exponents, but you do need to remember to change the sign of the divisor. And so there's not really an easy way to explain this like in words. So I'm just going to jump right in and start showing you. So what we're going to do is we are going to look at the coefficients of the first polynomial. So I've got a 1, a 4, a 1, and a -6. And I'm going to write those in order. I do need to always check and make sure that I'm not missing anything, that it doesn't skip from like x to the third to x. I've got 3, 2, 1, and then constant. So I have all the numbers, 1, 4, 1, -6. To the left of that, I'm going to draw a backwards L, and I'm going to put the opposite of this number in that box. So it's the opposite of this number in the box, or the half box, I guess, technically. Now, our first step is to bring down the first number. So I just bring that 1 down here, or whatever that first number is, and then it just becomes a pattern. I'm going to multiply, add, multiply, add. So I'm going to multiply -1 times 1, which gives me -1, and then I'm going to add straight down. 4 plus -1 is 3. So there's 1 down. Now I'm going to multiply, add again. I'm going to multiply these together, and that gives me -3. Add them straight down, I get -2. Keep going to the very end, multiply, and add. Now that I've gotten to the very end, I can't really do any more multiplying, adding, because if I multiplied, then my 4 would go over here, and that doesn't really make sense because there's no number to add it with. So we are going to write the answer, which would be taking the same variable, but we're going to start with 1 less than the highest degree. So since the highest degree was 3, I'm going to start with x squared, and I'm going to start by filling in my numbers, x squared, x, and then I'll have a constant. And what these numbers here represent are the new coefficients. So this one goes right here. This 3 goes here, and it was a positive, so I'm going to put a plus. This -2 would go here. And then I usually draw a line right here. The number at the very end represents our remainder. So I'm going to have a remainder of -4. So my final answer would be x squared plus 3x minus 2, remainder -4. So it seems kind of weird at first. I actually don't even fully understand like why this works, but I just think it's magical. And so we're going to keep practicing with this, but it's an alternative to using long division. That just goes a little bit quicker once you get the hang of it. All right, so we're going to use synthetic division. Notice that I jump from x squared to just a constant, which means that I'm missing a 0x in here. So when I write my coefficients, I'm going to have 1, and then 0, and then 3. So over here, I have my backwards L, and I get the opposite sign in there, which is a positive 1. Now, bring down the first number, and I start multiplying and adding. 1 times 1 gives me 1. Bring that together, or add it together, excuse me, is 1. 1 times 1 is 1, and 3 plus 1 is 4. My highest degree was a 2, so I want 1 less than that, so it'll be x, and it has a coefficient of 1. So 1x plus 1 with a remainder of 4. That would be my final answer. And if you don't write that 1 in front of the x, that's okay too. So remember that last number is always your remainder. All right, so We are going to now write out our coefficients. So we get 1, -2, -5, and 6. I wasn't missing any. I went 3, 2, 1, constant, so I'm good. What number is going to go in this box right here? -2. And so I'm going to bring down the first number. And then what numbers am I going to get along here? I gave you the first one, but go ahead and fill in the rest of them. I would have -2 times 1 is -2. Adding those gives me 4. This would be -8. Add is -13. -2 times -13 is positive 26. And this would give, this should be a -4. So then this would be +8. That will fix my problem. 3, and then -6. Sorry about that. And then 0. So this means that this polynomial was divisible by this. And when I write this, I get x squared, and then what would the rest be? -4x plus 3. And then the directions say to factor completely. So how would I factor this into 2 sets of parentheses? Draw my parentheses, split up my x's, 3 and 1, same sign, both negative. And so my final answer would be x minus 3 and x minus 1. I can only factor completely or factor further when my remainder is 0. If I had a remainder of 1 here, I wouldn't be able to factor that, even if it looked like it was factorable. So the remainder theorem says that if you have a polynomial with, as long as the degree is like 1 or more, in other words, it's not just like y equals 6 or it's y equals a constant. If it's divided by some linear factor and a is a constant or a number, then the remainder is the same as if you took this number right here and plugged it in for x. I just think it's kind of cool. So we are going to use synthetic division to find p of -1 for p of x equals all of this. What this means is, based on the remainder theorem, I've been given this right here. I've been given p of a, where a equals -1. So if a equals -1, I want to rewrite that to look like a linear factor. So how can I rewrite this to look like x minus a? It would look like x minus -1, which is x plus 1. So let's set up our numbers. What numbers are going to go across for the coefficients? We would get 2, 6, -5, and then hopefully you caught that there was no x term, so there should be a 0 there, and then -60. Backwards L, and I'm going to put my a value, or -1, in there. So when I do the whole process, what is my line of numbers under here going to look like? First number would be a 2, then we'd get -2, and that would give me 4. -4 added together with -5 is 9, negative. Multiply those, I get +9, and then I would just add those to get 9, and then this would give me -9, so I'd get -69, and that would be my remainder. What would be my final answer with the variables included? It would be 2x, 1 less than what I started with, so x cubed, plus 4x squared minus 9x, and then plus 9, with a remainder of -69. And there we go. So when it's phrased like this, it's really just another way of like writing what your starting linear factor is. Instead of writing x plus 1, they just wrote it as p of -1. It's the same thing. So that is synthetic division. If you have any questions, let me know, and I'd be happy to answer those.